Hi, my name is Katie Wong, and I'm an applications engineer here at Maxim Integrated. The MAX 828 switched capacitor voltage inverter provides a negative voltage reference, reduces power dissipation, and increases bias supply reliability. Today I'm going to show you how to use the MAX 828 to produce your own negative voltage reference. First, what is a voltage reference, and why do we need one? A voltage reference provides a constant voltage regardless of factors such as load, power supply variations, temperature change, and time. They are commonly used with data converters and in control and measurement systems. There are three common types of references: charged capacitor, Zener, and bandgap. Assuming an ideal capacitor, all the energy stored in the capacitor will be transferred to the load. This means that an ideal capacitor acts as a voltage source with zero source resistance. Since practical capacitors are nearly ideal elements, they are used at the output for DC power supplies in conjunction with voltage regulators or on their own. Thus, capacitors are used intensively in constant voltage DC power supplies. The Zener-based voltage reference is used in and out of avalanche mode. Most avalanche mode Zeners are used where they would be most stable, i.e. at a sharp knee, above approximately 5.5 volts depending on the semiconductor process. True Zeners at lower voltages work because of quantum mechanical tunneling. The majority of Zener noise issues are due to associated impurities on the die surface, which are overcome with buried Zeners by burying the Zener inside or below the die surface. The most common voltage reference uses a bandgap. This is a clever use of two transistor junctions with different current densities and hence different temperature coefficients. Two voltages with opposing temperature coefficients are subtracted from one another to make a nearly flat temperature curve. So what are the applications for a negative voltage reference? Well, as the name suggests, a negative voltage reference provides a negative voltage as a reference in an analog system, typically systems where you have a positive and negative supply. Now I know what you're thinking. Why do I have to use the MAX 828? Why can't I just use a Zener diode? The MAX 828, MAX 829 capacitive charge pumps invert the voltage applied to their input. For highest performance, use low equivalent series resistance capacitors. During the first half cycle, switches S1 and S3 close, and switches S2 and S4 open. The capacitor C1 charges the voltage at input. During the second half cycle, switches S1 and S3 open, and switches S2 and S4 close. C1 is level shifted downward by V in volts. This connects C1 in parallel with the reservoir capacitor C2. If the voltage across C2 is smaller than the voltage across C1, then charge flows from C1 to C2 until the voltage across C2 reaches negative V in. The actual voltage at the output is more positive than negative V in, since switches S1 to S4 have resistance, and the load drains charge from C2. The most common application for the MAX 828 is a charge pump voltage inverter. This application requires only two external components, capacitors C1 and C2, plus a bypass capacitor if necessary. To maintain the lowest output resistance, use capacitors with low ESR. The charge pump output resistance is a function of C1 and C2's ESR. Therefore, minimizing the charge pump capacitor's ESR minimizes the total output resistance. It's that simple. Using just two capacitors reduces the number of components in your circuit, thus reducing the size of your board. Compound this with a small IC package, and that makes the MAX 828 your space-saving solution. Most importantly, the low power dissipation makes this device highly reliable. If you want to find out more about the MAX 828, please look at the product page linked below. That's all for today. See you next time.